We are discussing here the transformer used in electrical system. First we discuss the introduction. What is the transformer? The transformer is a device in electrical system which convert one voltage level of energy into another voltage level. The transformer can accept energy at one voltage level and deliver at another voltage level. This permits electrical energy to be generated at relatively low voltages and transmitted at high voltages and low currents. That is, the basic electricity is generated at low voltages, which can be further step up to high voltages to transmit over a longer distance. Then, whenever it is to be used, it can be again converted from high voltage to low voltage. The energy transmitted at higher voltage having the lower current, thus reducing the line losses and voltage drops. The basics of transformers. Transformer is a static or stationary piece of apparatus. Transform power in one circuit to another circuit with the same frequency. Transformers raise or lower the voltage in a circuit with a corresponding decrease or increase in current. That is, current is inversely proportional to voltage. The basic of a transformer is a mutual induction between two circuits linked by common flux. It consists two inductive coils which are electrically separated but magnetically linked through a path of low reluctance. The two coils possess high mutual inductance. If one coil is connected to a source of the alternating voltage, an alternating flux is set up in the laminate core, most of which is linked with the other coil, in which it produces mutually induced EMF. If the second coil circuit is closed, a current flows in the second circuit. Thus, electrical energy is transferred from first coil to the second coil magnetically. The first coil in which electric energy is fed from the AC supply mains is called primary coil, and the other coil from which the energy drawn out is called secondary coil. The EMF equation of a transformer. Suppose N1 is the number of turns in primary winding, N2 is the number of turns in secondary winding. Phi m is equal to maximum flux in core in Webers is equal to Bm into A. F is equal to frequency of AC input. Therefore, the average rate of change of flux is equal to phi m divided by 1/4 F, that is 4 F phi m Webers or volt. Average EMF per turn is equal to 4 F phi m volts. If flux varies sinusoidally, then the RMS value of induced EMF is obtained by multiplying the average value with form factor. Form factor is equal to RMS value divided by average value, which is equal to 1.1. RMS value of EMF per turn is equal to 1.11 into 4F phi m volt is equal to 4.44 F phi m volt. Now RMS value of the induced EMF in whole of primary winding. E1 is equal to induced EMF per turn into number of primary turns. That is E1 is equal to 4.44 F N1 phi m is equal to 4.44 F N1 BMA. Similarly, RMS value of the EMF induced in the secondary circuit is E2 is equal to 4.4 F into phi m is equal to 4.4 F into BMA. From the above, it is revealed that E1 by N1 is equal to E2 by N2. It means that the EMF per turn is the same in both the primary and secondary winding. In an ideal transformer on no load, V1 is equal to E1 and E2 is equal to V2. Voltage transformation ratio. Now we will see what is voltage transformation ratio. For an ideal transformer, V2 by V1 is equal to N2 by N1 is equal to K, where K is the transformation ratio. If N2 greater than N1, that is K greater than 1, then transformer is called step-up transformer. If N2 less than 1, N1, that is K less than 1, then transformer is shown as step-down transformer. Input VA is equal to output VA. That is V1 I1 is equal to V2 I2. Or V1 by V2 is equal to I2 by I1. There is equal to 1 by K. Hence, currents are in inverse ratio of voltage transformation ratio. Now, suppose we see the transformer on load. When transformer is on load, in loading condition, practically no load primary current is not wholly reactive. The primary no load current has to supply iron loss in the core, that is hysteresis loss and eddy current loss. A very small amount of copper loss in primary, there being a no copper loss in secondary as it is open. Therefore, no load primary current I0 is not at 90 degree behind V1 but lagged by at an angle phi 0 less than 90 degree. No load input power is equal to W0 is equal to V1 I0 cos phi. Cos phi 0 is the primary power factor. Under no load conditions, the vectorial relation is as under. The primary current I0 has two components, one in phase with V1 known as active or iron loss component IW. It supplies the iron loss plus small quantity of primary Cu loss. Therefore, IW is equal to I0 cos phi 0. Second, the second component is in quadrature with V1 and is known as magnetizing component IU. Its function is to sustain the alternating flux in the core. It is weightless. IU is equal to I0 sin phi 0. I0 is equal to IW square plus IU square. The no load primary current is very small as compared to full load current. It is also 1% of the full load current. Also I0 is very small. The no load primary Cu loss is negligibly small. Means that no load primary input is practically equal to iron loss in the transformer. It is principally the core loss which is responsible for shift in the current vector by angle phi 0 is also known as hysteresis angle of advance. Now transformer on no load. When the secondary winding is connected to the load, now the transformer is on load. When the secondary winding is connected to load, the transformer is loaded and the secondary current I2 is set. The magnitude and phase angle of I2 with respect to V2 is determined by the characteristic of load. I2 is in phase with V2 if the load is non-inductive, that is resistive. I2 lags V2 if the load is inductive. I2 leads V2 if the load is capacitive. Now N1 I1 is equal to N2 I2. So I1 by I2 is equal to N2 by N1. The secondary current setup is O1 EMF, MF, MMF, that is N2 I2, and hence it is O1 flux, its O1 flux is phi 2, which is in position to the main primary flux phi, which is produced due to I0. The secondary ampere turns N2 I2 are known as demagnetizing ampere turns. The opposing secondary flux phi 2 weakens the primary flux phi momentarily. Therefore, primary backup back EMF of E2 tends to be reduced. Consequently, V1 gains over VE1 and causes more current to flow into primary. Let the additional primary current I2 days is known as the load component of the primary current. This current is in antiphase with I2. The additional primary MMF N1 I2 days set up its own flux phi 2 days, which is in opposition to phi 2 but is in the same direction as phi, as is equal to it in magnitude. Hence the two cancel each other. Hence it is revealed that the magnetic effect of secondary current I2 are immediately neutralized by the additional primary current I2 days, which is brought into the existence simultaneously with I2. The next flux passing through the core is approximately same as at no load. Phi 2 is equal to phi 2 days. N2 I2 is equal to N1 I2 days. Therefore, I2 days is equal to N2 by N1 into I2 is equal to K I2, where K is equal to N2 by N1. Hence, when the transformer is at load, primary winding also has two currents in it, that is I0 and I2 days, which is in antiphase with I2 and K times in magnitude. The total primary current is the vector sum of I0 and I2 days. Under full load condition, the ratio of primary and secondary current is constant. In actual transformer, there is some resistance exists in the primary and secondary winding. The secondary winding V2 is vectorially less than the secondary voltage V2 is vectorially less than the secondary induced EMF E2 by an amount of I2R2, where R2 is the resistance of the secondary. Hence, V2 is equal to E2 minus I2R2. Similarly, primary induced EMF E1 is equal to the vector difference in V1 and I1R1, where R1 is the resistance of the primary winding. That is, E1 is equal to V1 minus I1R1. The figure shows for non-inductive loads, resistive loads. Figure 2 shows the for the inductive loads. Figure shows the capacitive load I1. Colored leads V1 by I1. Thanks for watching and feel free to ask any comments. Please like and subscribe so that more and more videos can be produced. Thank you.